Hello everybody, today I'm going to be bringing you a little bit of a behind the scenes video of my Minecraft subscriber realm, and I'm going to be showing you guys my little mini computer that I built up to create the mines for the prison server. This video is going to be kind of similar to a tutorial, but it's going to be more of like me just documenting how I went about creating this and sharing it because I thought it might be pretty interesting. So what this machine is used for is creating mines on a prison server, and with this machine it allows you to have very specific percentages of each type of ore or block, and it also can fully randomize them within the grid that the mine is going to be. As some of you may know, I have had a couple prison servers in the past that I have built up before, and when I was creating the mines, it wasn't really particularly an easy process. I pretty much, since I couldn't have something that would actually randomize it, I would build the mines by having all the blocks in my inventory and kind of randomly guessing at, trying to make it as random as possible. The problem with this is that when you try to make a logical progression through the mines, the economics kind of gets messed up and you end up having very weirdly priced things. So going back to the percentages that I mentioned earlier, this is the table of values that I'm going to be using. I chose to make my mines 16 by 16 by 16, and these are the percentages that I'm going to be using to control how much of each block is introduced into each level of mine as you go up. So as you can see, the total will be 4096, but per layer is what we're going to be working with is 256 blocks per layer. What I'm going to do, now that we are building this machine in our actual subscriber realm to get it started, we need to choose the size of our mines. So our mines are going to be 16 by 16, so we're going to take just an easy block to mark that out. So we need to construct the first armor stand section, if you will. So we're just going to go ahead, make ourselves a little platform here. Nice and simple. And then we're going to make this 16 by 16 dimensions. So we're going to go ahead and use some little commands here. Smooth stone. There we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Alrighty, so here is our starting platform. So now we need to get our armor stands in so that we can use them to differentiate randomly when to place the blocks. So rather than putting armor stands on each and every one of these and name tagging them, I'm going to do a little bit of a command block little trick here. So basically we're going to start with just one of these command blocks to start out. So I'm going to go ahead and put this like here. There we are. And then I'm not exactly sure how this goes, so let me just try and do it in this menu first. Okay, so we're gonna have to spawn it like 2 above because it has to be, on top of the stone block. And then the event doesn't really matter for armor stands. You just have to have one so you can have a name, right? So I think like just put the name in there, maybe. There we go. So as you can see, it has a name. So we'll just copy that and put that into here like so. And if we get some redstone, you should see that this will summon this guy here. Okay, so now what we're gonna do is we're just gonna copy this along so that we don't have to, spend super amounts of time, copying this guy all the way across. So we're gonna go ahead, make our Y value 1 here, put this at 0, put the Z offset to 1. Actually, wait, I think this should be 0. There you go. There you go. There you go. And we'll just save this as random. Okay, now we can load it. Copy this guy over. There we go. Now we have a full line of command blocks. So now what we can do with this, so we can do some magic in here. Put that to 0. Put this red to 1. Offset the red to 1. Make this to 16. Put this to 1. Now we're going to save this whole line of command blocks. We'll save it under the same name because we don't need that previous one anymore. Switch that to a load. And then take this, put this all the way down. And there we go. So now that we've got that looking all lovely, we're gonna go ahead and do a fill command. So we're gonna /fill. Then we'll just do these coordinates to kind of have it correct, and then we're going to lower the Y coordinate, basically to fill it with a layer of redstone blocks so that we can power all of those command blocks. There we go. So now we have a full grid of random armor stands that will help us do our shenanigans. So now that we have that, we can just go ahead and clear all of those command blocks and everything out, because they are no longer needed. So now we have our full grid of armor stands in place. So now we're going to build one single module or cell for the random block placing on this grid here. So we're going to build our little system over here. So we're just going to build one cell to start to show you how it kind of works. We're going to need 4 command blocks for this. So these bottom 2 command blocks will be kind of the control command blocks of the machine. So these will just control the activation of all the modules that will be in the chain. And then these 2 are the ones that are actually going to be doing stuff, where this one right here will be executing once and putting the block randomly above one of these, and then this one will check if it did place and make sure to turn it off after it placed once per module. Alright, so since this is the bottom one, when this activates, all this needs to do is just get rid of the block below it. So let's go ahead and do that. Okay. And then this guy essentially needs to put a redstone right here, so that's going to be a +1 on the X and a -2 on a Y. So +1 on the X, -2 on a Y. Redstone block. We need this chain. Unconditional needs redstone because we want to make sure that we can turn the machine off. So that's what we need this for. Alright, so now we can work on the actual action part of the command block cell here. So this is going to be the one that is going to be the command block right here. And it's going to be the one that actually executes and puts a block randomly on the grid. So to do this, we're going to go ahead and do the execute command. We're going to be at random, so that means any of the armor stands. The type has to be armor stand as well, so type equals armor stand. I'm gonna get rid of this Minecraft part in the beginning because I don't think you need it, and it just makes your stuff big. Then we got name, and we want to do the same name that is of the armor stands, like this. Then we want to do the coordinates relative to the armor stands. Then we want to fill the block above. So we're just going to put it like 3 blocks above because I think it counts the block of the armor stand as the lower half. So we're going to put 3 there, and then we'll just do stone. And now, rather than just leaving it at stone, we're going to make it replace air. And the reason that we're doing replace air is that so that the next command block can check if it was able to execute or not. Because if it's not an air block and it can't place anything, then it won't execute and like change something that has already been put. So this one's gonna be a chain, unconditional, needs redstone. The reason we leave redstone needing on these middle two is that we can control to turn it off and stuff like that. And then basically this top guy, all he's gonna do is essentially turn the machine off. So to do that, we're just he's gonna turn this cell off. So normally when the machine is running, we're gonna have redstone blocks here and here to make sure that it's running. And this guy, all he needs to do is see that if this one executed, which is the one that places the block, we need to turn the cell off. So what we're gonna do, looks like it's gonna be a -1, -1. So all we need to do is just set block -1, -1 to air. Make this chain, and then this one needs to be conditional. And the reason it needs to be conditional is that it only executes if this one was able to execute. So now that we have both of these here, and this is powered on, we should see that when we do this, we get one single execution of a random block. So now we're going to be replicating this module across into many modules so that we can have a nice, good, even computer little thing. Alrighty, so now all I'm going to do is I'm going to make this now 16 cells long, so we can have a nice even number to work with for our future percentages and whatnot. And then just to label this, this would be our stone layer 0, so we're just going to go ahead and label it just so that we can have it for later. Okay, if we do a little bit of manual powering, I'm going to go ahead and turn all these on. Seem to have a little trouble here. There we go. So now that all of these are on, if we see we go ahead and give this an activation, we can see that we get a full, almost full little thing here. So as we can see, this one did not actually get rid of its thing, so it didn't turn off because this tried to place somewhere where there was already a block, so therefore it did not execute. So this is where it brings us to our next thing, where we need to loop this single execution over and over until it successfully places all 16 blocks in the certain run, if that makes sense. So real quick here, as we can see, when we power this again, let's go ahead and re-put this back into as it would be when the machine is on. So as you can see here, this redstone block goes all the way along, right? And yeah, it failed to fill. So as we can see, it goes all the way to the end, but we need it to loop back to the beginning. So we're gonna go ahead and do a little extra piece here that is going to, let me see what this would be, -17 maybe. This is basically just going to send the block back to the beginning to repeat again. And then we'll set this redstone block. There we go. Let's go ahead and test that real quick. Turn all these guys back on. We should see that this should loop now. Okay, looks like one too many. So just go ahead and reduce this guy. Bang. We'll take one of these as well just to clear this out because we don't want that sticking around. We'll just set this to air. There we are. So now we should see that this should go all the way along and does not do that. Oh. Okay, I see. There we go. There we go. So now we can see that we have it looping now. And basically this will stop looping when this line of redstone blocks gets turned off, or like there's a break in between, because these are the blocks that keep the machine going. So if we turn off this row, then the machine turns off. Okay, so now that we've got our way to loop it, now we need a way to turn it off. And the way turning off is getting rid of these bottom redstone blocks, as these top redstone blocks will get rid of themselves once the cell executes successfully. So the way that we're going to go about turning this thing off is we're going to need a giant AND gate, which basically says that once every cell has successfully placed its block, once everyone has done that, then it can stop looping and be finished for that cycle. So that way we have an exact 16 blocks placed for the module. So basically what we're going to do is get an output from all of these. And we're going to double invert the redstone output, if you will. And the way we can do that is just by a lot of redstone torches. So let's go ahead and invert it again, just to make life easy for us. There we are. And then now we're going to be putting redstone dust along here. And then somewhere in the middle, we have to off-center it by 1. So here we are with this. So as you can see, basically what this does is that once this has successfully placed 16 blocks, it will stop looping. But actually not yet. So in order to actually make this stop, we have to take an output from here to tell a command block to clear out the redstone. Let's go ahead and take one of these colors and do a little something like this. Alright, sorry for that cut. So all we've got here is our command block, and then we need to plug in some coordinates relative to it to basically clear out all of these redstone blocks, but really just this layer down here. So as we can see, to start with the first end, we need to go -2 on the X. So for the first set of coordinates, we'll go -2 on the X. And then for the second set, I believe it'll be -17. That's the Z. We don't want that. And we should see that if we power this, there we go. We get that bottom layer completely erased. Alright, so now let's go ahead and wire this up to the output of the AND gate. Basically, this will only execute once the entire module is like finished. Alright, so there we go. So basically what this does, say that this were all powered on, and we were to give it an execution, it will keep looping until all of these finish, and then once they all finish, it will turn the whole machine off. So that is pretty good for us. Now I think we need to implement some of the circuitry that gets us starting here to start the machine up. Let's go ahead and do that real quick. So we're going to have our power on block right here. Going to have our command block. Alright, so basically let's start off with our basic template. Redstone block. Okay. So for this top corner of our thing, we need to go 1, 2 on red, so that's all we need on that, really. 2 on red, and for the next one we need to go -1 on Y, and I think 17 on here. Let's see what that does. Okay, so this turns it on essentially. Now to also turn it on, we're gonna need to actually put a piece of redstone underneath this first guy here. Now we're going to use a structure block for this, and you'll see the importance of that later. But yeah, we're going to use a structure block for this. So essentially we just will save this guy, I guess. So let's go ahead and make this one -3, I think. Yeah. 1 as well. 1 as well. Okay, and then now we're just gonna save this as start. So I'm gonna save this. What we're actually gonna do is put a redstone block in here. So we're gonna save this. Now we want to put this into a load. Okay, so as we can see here, when we press this button, it will go ahead and start the machine. Go ahead and get into some placing, and then once it has placed 6 blocks successfully, it will turn off. So if we go ahead, let's make another little control thing to clear our playing field. Like this. We'll just get a button here, command block. Go to each corner. Okay, and then copy that command over to here. So as we can see, when we turn this on, we get an execution of 16 pieces of stone. And if we need to clear it, we could just do this. So as you can see, we have 1 piece of redstone that goes all the way across until it is fully executed the whole cycle that is needed. So now we're going to move on to the count controller. This is also known as a count control loop. So this will easily repeat this entire process a couple of times without you having to just sit here and press the button over and over again. Say if you wanted 8 iterations of 16 to fill this up, that will make it so that you don't have to sit here and keep pressing the button every single time. Okay. So basically, this count control loop will feed into this power button as well. Let me check something real quick. What does this do? Okay, so essentially we'll just bring this guy over here. Alright, so to make our count control loop, we're going to use some droppers as well as hoppers. Like this. Take some redstone. Bang, bang, bang. Okay, so let's go ahead and put this guy here. And then we'll put our second dropper right here. This guy will go into, actually no, let's go like this. There we go. And then once this detects an output or something that's inside of it, we're going to go ahead and trigger a dispensing of this. Let's put this on this side actually. Like here and here. Bruh. Okay. Bang bang. Like this. So that will restart it. Then we also want to go ahead and dispense that. So I'll explain this in just a sec on what is going on here. Okay, let's go ahead and make sure that this reaches over here. I want about, how much delay are we thinking? Probably like a 2 tick delay. It's pretty good. So let's go ahead and demonstrate what I actually just did for those that are confused. So say, for example, on the first mine, well, I don't know the exact data, but let's say that we want 50% stone here. So since this is a 16 by 16, 50% stone will be 8 iterations of 16. So if we want to repeat this machine 8 times, we can use our little count control loop so that we don't have to keep pressing the button over and over again. So first off, we're going to put 7 in here. We're going to put 1 less than the amount of iterations because we are going to be pushing the button once. So we're going to put 7 in there. And we're going to hit this button once, and as you can see that this machine will cycle. It will cycle 7, or no, it will cycle, well, it was supposed to cycle. What happened here? Alright, so as we saw, that whatever circuit I tried to remake, that did not work. So we're gonna actually just straight up use the one that I already had, because I think there's some issue with some bud powering stuff that I'm not too familiar with. So let's just you know, use what we already did. I'm assuming. So I think we need to put some more delay on this hoe. Alright, now we're gonna put 7 in here and see if this works better. There we go. Alright, so as you can see, this will iterate 8 times until it fully successfully completes the placing for all of those. And that is our count control loop. So one next improvement, as you can see, we only have one redstone block going across here, and as the board gets more and more filled up, it will be harder and harder for it to find open spaces to try to put blocks. And as we can see, we only have one redstone block going across here, so now we're gonna, after this finishes, if it can, we're gonna be upping the speed and efficiency of this machine by 8 times. And the way that we're going to do that is quite simple. So first off, we're going to go ahead and put this down by 1. Turn this into a save, and then make this guy 16. Okay. And then what we're going to do is grab a regular block so that we can place here. And we're going to go ahead and do it like this. Now the reason we want to skip one for every redstone block is because the command blocks need a chance to power and unpower. So you can't just have them like a full line. Alright, so let's go ahead and save this and then load it. But bring the load up by 1. So now, if we go ahead and reset, we should see that if we do the same thing again, let's go ahead and put 7 in here. We want 8 iterations. As you can see, we will be able to go a lot faster. Now, because it's a lot faster, we have to change some of our timings back here. So we need to make this go a little bit quicker, if you will. Alright, so let's go ahead and clear the board. Got 8 iterations loaded up, 7 in the controller, 1 with the button press. And there we are. So as you can see at the bottom there, we have a lot more command blocks working. So this will execute a lot faster. Because since these need to, you know, essentially these will only, the redstone blocks that tell the thing completed, they only disappear if it's successful. And when you get to towards the end, it's gonna try and place somewhere that's already placed, and it's gonna say, hey, we can't do that, so it's gonna stay there, and it needs to keep trying to find a random one to place as often as possible. So the more you try, the faster it'll be. That makes sense. because every time this command block executes, it's trying, oh, 1 out of 256, if there's air, place a block. But sometimes it could check here, it could check here, it could check any of these. You just have to wait till it, you know, somehow randomly lucks in on one of the open spots. That's why towards the end here, you could see that it's getting very, you know, it's struggling, really. That's the only thing about this, is that the reason that you have to go through this is that when you place a block on one of these random ones, there's no way to take that random place out of the block pool to try the next time. So you have to kind of just make it execute or try again as many times as possible. Now sometimes on the end here, you might as well just go help it out. You know, might as well just help it out on these end bits. But if you were to leave that run long enough, you probably could get a result. Now I did see a little thing that I want to change on this real quick. Just on the spacing here, I want to try and put these with the starting guy here, just so it looks a little bit better. And honestly, probably one there as well. Let's see if this works. So let's go ahead and save this. We'll save it by 617 this time. Now let's load it, but one up. Let's clear this. Put 8 in here, or 7 really. And go. Okay, so as you can see, that doesn't really work, what we tried there. So let's go ahead and fix ourselves. So this guy at the end is not something we could do, unfortunately. Alright, here we go. Huh. I'm rather confused on why that does that. Alright, I'll fix it, and then next clip we'll continue. Alright, I went ahead and cleaned this up just so that this looks a little bit better. All I did was make this last command block that would place the block here. I just made that, place that back at the beginning, and then we have an air block right here. So, just a little fix to make it a little bit better. Actually, I don't even think we need this end guy. Yeah, we don't need this guy. So this should still work perfectly now. Okay, so that is the basis of our computer now finished. So we'll have a couple other little things that are making it easier to generate a layer. And yeah. Alright, so now we're going to introduce another piece of this mechanism, which is the cartridges. So basically what the cartridges are is that, as we can see, this line only does stone. So we need to be able to switch that out for different blocks because, you know, we don't want to mine with just stone because I don't think that would be very fun. So we're going to call this, structure swap, okay? Basically, we just want to save this row right here so that we can switch it out fairly quickly. So, as we can see, let's go ahead and reset these offsettings. Still want it to be 16. I think we want to be actually minus 16. Nope, 16 on this. Okay, so now this one, swap, is taking this cartridge right here. So we're going to set this on load, right? Let's save it real first. Put that on load, and then we're going to take this guy, and we'll put these here for later use. So now we're going to take this over here. Let's go ahead and move this guy over this way. We'll put him like right about. We're gonna need a little bit of room for something else here. And then we'll have our cartridge switcher. As we can see, if we were to load it up over here, we need to switch these out for different blocks, and we'll switch it out for different levels of the mine. So we can see that this is only stone, right? So in order to kind of switch this, we would have to go into here, change that block. So let's say we change it to cobblestone, and then we would have to break this block and place this all along here, which is a bit excessive for the efficiency that we're looking for. So we're gonna make a cartridge maker that will basically take one command block and duplicate it along into the entire line, and then it'll save it in the cartridge so that we can go and load it up and continue using our machine. Now I know these words might sound like gibberish, but I think that if you just try your best to understand, it'll make sense soon enough. Again, this video is not as much a tutorial, just me documenting how my machine works, because I think it's kind of cool. Alright, so we're going to have our key block. So we'll have our key block right here. And essentially, let's go ahead and have a look. Okay, so what we need to do is we need to have our same control command blocks that we've had. So yeah, control command blocks essentially just means that it, moves the redstone block power device across the line to go ahead and continue the machine's you know what I meant. So this will just be nope, ziplock -1 air. Impulse unconditional needs a redstone, perfect. Then this guy will move this. He'll be -2 now, and he'll be -1, and he needs to put a redstone block. Nope. Alright, he's chain, unconditional, always active. So theoretically this should go like that. There you go. There you go, there you go. So now we need to push these guys all the way along. Alright, and now we need our clone command to get sturdy. So basically the clone command, all it needs to do is clone this block to go and place here. Okay? So the numbers on this, we're gonna go ahead and get rid of this. So we're gonna do /clone. If I can spell, God. Alright, so we want to pick the area of where we want to clone, and then the destination of where we want to clone. So the area of where we want to clone is just a single block, so it's going to be down 1, 2, 3 on Y, down 1, 2, 3 on Y, -1 on Z. So for the first set, down 3 on Y, back 1 on Z, down 3 on Y, back 1 on Z. Then the destination will be down 3 on Y, back 1 on Z, and back 1 on X this time. So as you can see, if we have this guy placed here, it does nothing. That's so fun. This is supposed to be save also. Ah. You boys a little bit dumb-dumb sometimes. Okay, so now let's just get this guy all the way across. And then we can put one of these guys right here as well. What? Alright, my fault. There we go. Oh, why doesn't that get rid of that? What? Oh, because there's nothing in there, bro. What is happening? This video is going to be very all over the place. Whatever. Alright, please tell me this works. Alright, and then it should have saved it as well. Okay. That was a lot more frustrating than it should have been. Okay, so let me show you what the use of this is. Okay, so we have stone here. Let's go ahead and fill it with 50% stone. Let's do this first while we move around. So 7 in there, 1 in here. That's 8 iterations. We'll get 50% stone, okay? Now we're going to take the stone cartridge. We're going to move it over to here. Alright. But first we need an extra command block. We need down 1 and then back 1, 2. So down 1, back 1, 2, like this. Like, why would I ever need a redstone lamp, bro? I just want a redstone block, chief. Come on now. Why do I gotta type this whole thing out? Okay, there we go. There we go. Okay, so basically, let's restart this. Okay, let's go ahead and go here. We're gonna go ahead and do cobblestone, and then we're just gonna change the command block cartridge to. Did I just delete something? We're gonna change this to cobblestone for an example. Okay, put that along. Automatically gonna save. Now that this is done, we can go ahead and hit this load button. Now you can see that this whole thing is cobblestone as well. Let's say we only want let's say we want 25%, so we'll put 3 in there, 1 in here, and now we can see that it starts to fill with cobblestone instead. Now this is all good. We can, determine our percentages of what we want and all that, do our cartridges, we can move them into here. That's all good and nice, but when we want this will only do 1 layer, as we can see here. Now there's not really a way to do a randomized with 3 dimensions, X, Y, and Z, without getting complicated with, a level of armor stands on the bottom as well as a sideways panel of armor stands. So there's no real way to, deal with 3 dimensions and random stuff as well, without just getting overly complex. So this is an issue that I ran into where, let's say I wanted to work on the next level up, right? So I'd have to make the cartridge for stone again. So, yeah, I have to make the cartridge for stone again. But the thing is, I have to go in here, and I have to adjust these numbers. These numbers right here at the end, I need to up by 1, right? I need to up them by 1. And then now we have stone level 1. Okay. Duplicate that across. And then put that in here. And then put, So the thing is, when you get to doing multiple layers, you have to keep going in here to change these numbers, right? And you can't just click to the numbers, which is the annoying bit. You have to use the arrow keys and then go in here and move the numbers. And you know, that's just a little bit of extra inefficiency, really. So I wrote a little program to go ahead and auto complete the kind of go ahead and auto complete these commands for me, and I'll show you what I mean by that real quick. Alright, so as you can see here, this is the little program I wrote. This is what I'm learning in college, by the way. So this is the program that we use. But essentially what this does... Okay, as you can see, this is a program that helps me do these things a little bit easier. So we have, please enter a block. We want to use stone. This will just be the name of the game, name of the item in the game. And then enter a starting Y level. So this is like the relative at the level 0. So that's going to be, I think it's going to be 4 for me. But I think it might actually be 3. I'm not sure. I think it's 3. Number of layers, we're going to have 16 layers. And then as we can see here, this will completely do all of our commands right here. Now what we can do with this, so we can copy it, open up a text document, and paste them into here. So now we have all of these here, where if I play Minecraft on the computer for a little bit, I can just copy and paste these into the game rather than having to go in and, you know, select all of those things. So that's my little program that I wrote. As you can see, if we try it again, let's say we wanted to do iron underscore ore. Same level, let's do 4 and then 16. Bang. Get all of our things done. And there we go, we have them in a notepad now. So yeah, that is that. With that being said, that is going to be the end of the video. Thank you all for watching, for anyone who made it to the end. And I know this was not maybe the most correctly formatted documentation, but I just wanted to show you guys how this works. So yeah, okay, bye bye.